Okay, so up to the last class, do you have any question, any confusion, any doubt? I hope no. So if there is any, you can ask. Is the screen visible? Okay. Okay, so in the last class, we are solving one problem related to epicyclic gear train. Okay, so where the problem statement says that basically this epicyclic gear train, it consists of a sun wheel S. This one is the S. Okay, the sun wheel. Okay, and sorry, this is the S sun wheel. Okay, a stationary internal gear E. So this annular gear having the internal teeth. Okay, or the bigger gear is nothing but this particular gear E. Then there are three identical planet wheels P which are carried on a star-shaped planet carrier C. Okay, so three identical gears, planet gears, which are in mass with the sun gear as well as the ring gear or the annular wheel. They are identical in nature, denoted by E P, okay, and they are being carried by this particular star-shaped planet carrier. Okay, so this is pivoted here at the center of this particular uh, planet gears, and also here at the center of the sun gear. Okay, this is the carrier C. The planet gears are identical, denoted by small p. This is the sun gear S, and this is the external gear E. Okay, so now what is being given, the size of the different tooth wheels are such that the planet carrier C, this starship planet carrier C, it is rotating at 1/5 of the speed of the sun wheel S, and it is being said that the minimum number of teeth on any of the wheel is 16, and the driving torque of the sun wheel is given as 100 Newton meter. You need to find out the number of teeth on different wheels of the train, as well as the torque necessary to keep the internal gear stationary. Okay, so for this kind of epicyclic gear train, as we have in the last class we have discussed, so we are going to make a tabular form where we show the motion of various elements under certain conditions of motion. Okay, for that what we consider the different conditions of motion, and based on under that particular condition of motion, what kind of motion is there on each and every uh, element on this particular gear train system is that is being understood. Okay, so for that what we have done, so first column we are considering the condition of motion. In the next subsequent columns we are considering all the different elements which can have independent motion. So first we are considering the arm C, that is the star shaped arm carrier C. Okay, then we have considered the external gear E. Then these three planet gears, they are identical, everything is similar. So if we know about one, then basically that is the same kind of motion that will be valid for all the other two. So any either of this particular planet gear you can consider gear P, and also the sun gear S. After that, this particular table actually we have completed in the last class itself. So we have considered initially the first condition to be a fixed arm condition, and we have given +1 revolution to the gear E, that is the external gear. So that's why we can write for arm C it is fixed, that means motion is 0, and gear E +1 has been given. So now P and E, this planet gear and this external gear here, okay, they are what kind of, they are missing is internal missing, because this E gear has internal teeth cut and they are internal MS, so their sense of rotation will be in the same direction. That's why it is be positive only. Okay, positive dE by TP will give you the motion of gear P. Now from there, okay, once the planet gear has got the motion, now this planet gear is in terms in external mass with this sun gear S. Okay, so now if it is externally mass, so the sense of rotation for both the gears will be different. So if gear P is rotating in a certain direction, so gear S, that is the sun gear, will rotate in the opposite direction. That means if for gear P it is positive sense, we have to consider negative sense of rotation. Okay, so we are putting negative. So now how the motion is coming? So from initially we have given motion to this element E. Okay, from there we have obtained motion at P, and now the P becomes driver for the S gear. Okay, so two steps are there. So for gear S, how we can find out the motion for this element, negative of TE by TP into TP by TS. Now TP TP gets cancelled, so it will remain minus TE by TS. After that, what we consider? We are considering still the arm is fixed, but now we are giving plus x number of revolutions. So just multiply with x all the motion of different elements. So 0 into x equals 0. So this becomes plus x. This is x into t by tp. This is minus x into t by ts. Okay, this is up to x rotation. Now what we consider? We also consider giving motion to all the elements. Okay, that is we are also giving motion to the arm also, and in the meantime, like all the elements are going to get motion. Suppose let's consider we are adding y motion. Okay, adding y to all the elements. So from there the total motion will be this 0 plus y equal to y plus x plus y equal to x plus y, and similarly this will be y plus x into t by tp, and this will be y minus x by t into ts. Okay, this is the motion for this different elements. This is for arm C, this column for gear E, this column for the planet gear P, and this column for the sun gear S. Okay, this is what we have obtained by doing this particular analysis. Okay, now what we consider? Now we are going to consider the different conditions which are given in the question and try to equate those motions with the given conditions. Okay, after this class, everything is clear. Let me know. Yes or no? Hello, am I audible or not?
Yes, sir.
Okay, so after this, class, any confusion? No condition, right? No condition. So
No.
now we go for the given conditions as per the question. So according to question, what is the condition? It is being said that sun wheel S makes 5 revolution for 1 revolution of arm C. That is, it is being said now. So the planet C rotates at 1/5 of the speed of sun wheel S. Ultimately, from there we can say the sun wheel S it is making 5 revolution for single 1 revolution of arm C. Okay, so now that is some motion of S and motion of arm we are talking about. Okay, so now we already have the different motion. This is for the motion of the arm C. This is for the motion of gear E. This is the planet gear. Okay, and this is for the sun gear. Okay, so now this motion, that means we can have some numerical value for that. So arm motion is y. So y equal to 1, and when y equal to 1, what happens to the motion of your sun wheel? So we'll also go for the sun wheel. So sun wheel motion is this one, y minus x into t by ts. So this will be equal to 5. So y minus x into t by ts equal to 5. Okay. Also, as per the question, if you come back to question, okay, so it is being said that a stationary internal gear E and 3 identical planetary B. That means stationary internal gear E means what? Whatever is the motion of gear E, that is this mass. Okay, stationary means it is 0. Okay, that means x plus y, that is the motion of E. So while E is stationary, that's why x plus y, that is the motion of E, equal to also 0. Okay, now this equation y equal to 1 give number 1, this is number 2, this is the third condition. So from there, by solving, what we can get? X equal to, so we can get x equal to minus y, and y equal to 1 already is there. So x equal to minus 1, y equal to 1 already we have. Okay, so now these values if we put here in number 2 equation, this one. Okay, so after solving, what we have obtained? We have obtained the relationship to be t to be 4 times ts. Okay, so now after that, if you go for the given condition, this means that the minimum number of teeth on any gear is 16. Now let's consider the minimum number of teeth on the sun wheel S. Okay, so then what will happen? So TS will be then 16, and from here T will be 4 times of 16, that is 64. Okay, And now if we this particular relationship between the teeth, if we go for the geometry relationship between their size, then what we can write, pitch circle diameter for E. So now here this one is E, okay. So this mass is nothing but actually the pitch circle diameter for P. So what we can write, so this is nothing but how much? So this equal to this diameter of planet wheel is plus the diameter of sun wheel S plus once again this mass is once again we can consider diameter of planet wheel P. Okay, that means 2P diameter of twice the planet wheel plus a single sun wheel diameter of single sun wheel equal to the diameter of the external wheel E. Okay, D equal to from diameter you can write 2dp plus ds, right? So that is what is being written, d equal to 2 into dp plus ds. That is the pitch circle diameter. Okay, so now this same relationship we can extend to the number of teeth, and we can write te equal to twice the number of teeth in p plus ds. Okay, because the number of teeth are proportional to the pitch circle diameter for those different gears. Okay, so now after that what we are doing, so we are just doing like te already at is obtained. Okay, so we can write, we can use this value here. Okay, 64 equal to 2 into tp plus the number of teeth in sun will already considered as 16 plus 16. So from there tp becomes 24. So now TP is obtained. T as we have considered to be 16 by considering the minimum number of equation. Then T also 64. So the number of teeth in for all the wheels, that is the planet gear, sun gear, as well as the external gear, that is obtained. Okay, so this completes the first portion. Understood? Let me know. Yes or no? After this much, you have understood or not? Let me know. Hello, Rishikesh, Vermiki, Emil, Rehan.
Yes, sir.
Yes, sir. So you could understand up to this much or not? Let me know.
Yes,
Then
sir.
only I can move ahead, no? No hustle.
Yes, sir.
Okay, so now that means the first part is over. Okay, next part also they are asking you need to find out what the torque necessary to keep the internal gear stationary. Okay, so now which one is the internal gear? This is the internal gear. Okay, and it is being said that the driving torque on the sun wheel is 100 Newton meter. Okay, so driving torque at the sun wheel is given as 100 Newton meter. So now this is the sun wheel. Okay, now if I think of the torque at E, that is the external gear. Okay, then we know that power is given by P equal to force into velocity, that is for linear motion. Now the same thing is valid for angular motion also. Okay, so that will be equivalence of force in rotational motion is tau, that is the torque, and this linear velocity becomes angular velocity omega. Okay, so in case of rotational motion, P equal to tau to omega. That is the expression that is valid. Okay, so now torque at E, for torque at E, what we can write? So whatever is the power at S, that itself is equal to the power at C, because the C is nothing but the carrier. The carrier is directly attached here, okay, pivoted here, and the external pivoting at the extended end, okay, extended arms. We have got the planet wheels. But so actually, whatever is the power available here at the sun wheel S, that will get directly translated to this particular carrier C. Okay, so that we can equate. So this power at S means what? So by using this P equal to tau into P or omega, so torque into the angular speed at S equal to torque into angular speed at C. Okay, so now the torque driving torque at S is already given as 100 into the omega S, that is omega for angular velocity, S for the at particular location S we are talking about, and which is equal to torque on C into omega of C. Okay, now from here what we can write, torque on C equal to 100 by 100 into omega S by omega C. Okay, and omega equal to, all of you already know, 2 pi n by 60, that we can use. Okay, so now this becomes 2 pi n for S, okay, divided by 60 into 2 pi into n of C. Divided by 60, 60 get cancelled, 2 pi get cancelled, so this is 100 into ns by nc. Now what is being given, ns by nc, this rotation is already given as we already have here, or from here also the same thing. C rotates 1/5 of the speed of that wheel S. So ns by nc equal to 5. Okay, speed of the sun wheel is 5 times that of the your carrier. Okay, so by multiplying 100 with 5, this is the torque on C is nothing but 500 Newton meter. Now what they are asking, is you have to find out the torque which is necessary to keep the internal gear stationary. Okay, so what we have obtained, the driving torque, that is given. We have found out the torque on C to be 500 Newton. So now what they are asking, we have to find out the torque required to keep the internal gear, that is E, stationary. Okay, then it will be 500 is ultimately the torque at S plus the torque at E should be equal to C. Okay, so this will be torque at E equal to torque of C minus the driving torque at S. This is nothing but 500 at C. Just now we have obtained, and this is driving torque is given as 100. So 500 means 100 equal to 400 Newton meter is the torque required to keep the internal gear stationary. Then it completes this particular. Okay, so this is how we solve some problem which is related to your epicyclic gear train. Let me know whether I have understood or not this particular question. Good, Paul.
Sir,
Understood?
not sir. No. I just joined it, sir.
Partha,
Sir, can you show the screen?
Emil,
So we'll go through it again.
where is the confusion?
Sir, as for now, sir, I'll go through it again, then I'll let you know, sir.
Hermiki, Rishikesh,
Yes, sir.
understood?
Yes, sir. Clear, sir.
Yes,
Hermiki, clear?
go through again, sir.
Rehan,
Found any problem?
Yes, sir.
Hermiki, your actually voice is distorting. Please repeat. Okay, then we can move ahead to the next question. Is it okay?
Okay.
Okay, by the way, do your class test 2 is approaching, na?
Yes, sir.
Okay, so the class test 2, do you know about the syllabus?
No, sir.
No, sir.
Okay, so for class test 2, your syllabus will be your that in the last class test, even though you have the cam profile design was like included, but none of you could do it. So cam design is there, still there. Okay, one cam design problem you can expect. So cam profile construction, that is there. Okay, and some related small theory maybe that may be there from the cam this module and the gear module. Gear module and your gear problems. Okay, so this gear train is not included. Only the first part, that is normal gear drive up to that. That means this kind of problem, gear train kind of problem, will not come. But from the first part, that is the normal gear drive, okay, it will come. Understood?
Yes, sir.
This is for class test 2. So cam design problem you try. Okay, this time all of you should be able to do it. Do you have the confidence now? What are the stages involved in cam profile construction? All those things should be written properly. Okay, all those assumptions, all those scale, etc., whatever you have considered, and as per that, like first of all, you have to draw the write the given data, the scheme of motion for different, suppose ascent stroke, descent stroke, etc. And as per that, by considering proper scale, you need to draw the displacement diagram. After that, you need to write about the assumption that you consider, that is the kinematic inversion. Let's consider cam is stationary. Okay, follow this rotating around the cam in which direction, etc. So that kind of thing you will write, as well as what is the value of r that you have to consider for drawing it. Okay, drawing the circle, those things you will write. Okay, and also be mindful about whether it's a offset type of cam and follower arrangement that we are talking about, or whether it's a inline type of cam design you need to do. Okay, so based on that, if it is offset type, then you know how to draw. Similarly, if it is kind of inline, just follow the procedure for inline cam profile construction. Okay, also be mindful about whether it is roller follower or knife edge or your other type of follower. Okay, based on that, your the trace point will be varying, right? For roller follower, it stays at the center of the roller, but your in case of knife edge follower or other flat face follower, okay, directly it is at the contact point with the small surface. Okay, so those things be mindful about. And at the end, like when you construct the cam profile, so which cursor you show, which of that particular curve, because there will be so many things that will be drawn on that particular diagram, no? So which one of that finally is the cam profile, you with your cursor is just show it. Okay, is that clear? So say something,
Yes,
then
sir.
only I'll be able to understand. Okay. Similarly, from this gear module, okay, so theory as well as gear like some problem related to like your those finding out contact ratio, etc. That kind of thing. Okay, those problems you have solved on different problems. So that kind of problem you try. Some other problems also you try by yourself, and that will be there. And gear train is not included. That means whatever problems we are solving in the last class today, etc. That type of problem, that is epicyclic gear problem or simple gear train problem or compound gear train problem, those problems are not included for class test 2. But others will be there. Is that clear?
Yes, sir.
Okay,
Yes, sir.
so none of you should have any confusion with the syllabus for class test 2 then. Okay, so if everything is clear up to this much, we can move ahead and we can try to solve another problem. Shall I move ahead then? I hope that to be a good ahead direction. Okay, so this problem statement says there is an epicyclic gear train, and there is an annular wheel that is also there in the epicyclic gear train. That is annular wheel A. Okay, it is having 54 teeth and it is messing with a planet wheel B, which in turn in mesh with a sun wheel C. The wheels A and C are coaxial. That means their center of rotation is same. For A, this A is the angular wheel, C is sun wheel. The wheel B is carried on a pin fixed on one of the end of the arm P, which is rotating about the axis of the wheels A and C. Okay, so this is the axis of wheel A and C. So wheel B is the planet wheel. So definitely it will be matched with the sun wheel as well as the angular wheel. Okay, and it is the axis of rotation here. Okay, and it is carried on a pin which is fixed on this particular arm P, and this is the arm location. Okay, and this particular wheel P is rotating about the axis of the wheels A and C, which is the same. A and C axis is this one only. If the wheel A, that is the annular wheel we are talking about, this one, bigger one, if the wheel A makes 20 rpm in clockwise sense, clockwise direction, 20 rpm, that is given. And the arm, it is rotating at 100 rpm in the anti-clockwise direction. Arm rotation is given in the anti-clockwise direction, making 100 rpm. Okay, and the wheel C has how many number of teeth? TC is given as 24 number of teeth. Then you need to find out the RPM as well as the directional sense of rotation of the sun wheel C. Okay, so what is given? It is given. So RPM for A is 20 RPM in the clockwise direction. Arm, it is moving in the anti-clockwise direction with how much RPM? 100 RPM. Okay, sorry. And the number of teeth on gear A, that is TA, is given as 54 and TC is given as 24. Okay, now once again, sometimes this for this kind of problem, small problem, this figure may or may not be given. Okay, most of the time it is given. Sometimes it might not be given, being a very simple type of gear train, Epicyclic gear train. So from the statement, problem statement, you should be able to simply draw it. Okay, so annular wheel means the bigger wheel, which is having the interior or internal teeth. Okay, sun wheel is remains at the center. Planet wheel, it is all of you already know. Planet wheel, it is there in this particular location. Okay, and it also the arm connects uh, the arcade is the particular planet wheels. Okay, which gives us the both the type of motion, that is around the sun wheel also it can move, and about its own axis also it can have the motion. So now once we have this kind of problem, so we make the tabular form for showing the motion of different elements. So what are the different elements present here? We have got this particular annular wheel A, we have got this sun wheel C, we have this one single planet wheel P, and also we have the arm P. So four different elements motion, and they will have independent motion. Okay, four different elements we have to consider, and the motion, the type of motion that will consider. Okay, or the condition of motion. So we are going to make that particular table. So motion of various elements of the gear arrangements are. So first in the first column we will be showing the condition of motion. Then the different elements we know, that is the arm P, then the wheel sun wheel C that is there, then the planet wheel B is there, and the your external or the annular wheel A is there. Okay, so these are the different limits. So first what we'll consider, we are considering as the arm to be fixed, and this C is rotated through +1 revolution, and +1 we are considering anti-clockwise direction to be positive sense. Okay, so all those anti-clockwise directional movement will be considering in the positive sense, and subsequently if there is like clockwise movement is there, then we have to consider it as the negative sense. Okay, so this plus or minus, it just gives you the sense of rotation. Okay, so now, oh, if arm is fixed, so what will be the motion of arm? Definitely that is zero, no motion, and we'll see is being given +1 revolution, so motion is +1. Okay, now from this, okay, what will be, how it is going to get the motion? So this will be is you are giving motion to wheel C, right? Okay, so it is in C wheel C, that is the sun wheel, and this particular planet wheel, they are in internally meshing or externally meshed? External meshing or internal meshing? Hello, who can tell me? Rehan? So this is external meshing. That means if we are considering wheel C to have positive sense of directional motion, then it will be in the negative we have to consider. So negative of Tc by Tb, that is the motion of wheel B. Now from there, once this particular motion B rotates, so B and A are in internal. Okay, now once again the motion will be given to the wheel A through this particular wheel B, but it will be in the same direction. So once again negative will prevail, negative will remain same. So negative of Tc by Tp into Tb by Ta. So B Tb Tb will get cancelled. It will be minus of Tc by Ta. After that, we'll just consider the same thing, that is arm still fixed, but we'll see is now being given plus x revolution anti-clockwise. So plus x will be multiplied everywhere. So 0 into plus x equal to 0. This becomes plus x. This is minus like x multiplied by this value minus of Tc by Tb. Here also x multiplied by this value minus of Tc by Ta. Now we will be adding y motion to all the elements. So that gives us the total motion of arm P to be 0 plus y equal to y. This is x plus y. This is y minus x of Tc by Tb. Similarly, for wheel A, it is y minus x of Tc by Ta. Okay, so this is what we have made the the tabular form where we have shown the motion of various elements. So these are the final motion in terms of x, y, tc, tb, etc., etc. Now what we'll do, whatever are the given conditions that is given, so these motions will try to equate with them. Okay, so what are the conditions that is given? So it is said that wheel A is making 20 rpm in the clockwise sense. So which is for wheel A? So this is for wheel A. So that means this particular value is equal to 20, but it is in clockwise sense. We have considered anti-clockwise to be positive, so clockwise we have to consider negative. So this y minus x by x into Tc by Ta equal to minus of 20, because anti-clockwise is considered as positive. So clockwise will become minus. Next, about arm P, it is being said that it rotates at in the clockwise direction and 100 rpm. So arm value, arm motion is this one, y. Okay, so y equal to plus of 100. Okay, so now once we know about y value, if we put it the value of y in 1, so we'll get 100 minus x into Tc by Ta equal to minus 20. So from there, Tc by Ta, that is also known because it is given. Ta is given 54, Tc is given as 24. By putting those values, x is found to be 270. Okay, so now in the table, if you see, there is the wheel C which is giving the motion to be x plus y. Okay, so now speed of wheel C that is needed to be found out, n of c, that is nothing but x plus y. So we have the value for x. Okay, we also have the value for y. Okay, so by putting them, nc equal to 270 plus 100, that is 370 rpm. And as it is positive, positive means which direction? So anti-clockwise. Okay, so this completes this particular problem. And this is a very small one, easy one. That's what we need to do. First is, what are the stages involved? Who can tell me? You people are totally inactive or what? I am unable to understand whether you people understand the things or not. Because there is no response from your side. Rishikesh, are you there? Nohosal?
Yes, sir.
Emil?
Yes, sir.
Jeremy,
Yes, sir.
Nilutpal,
Yes, sir.
Partho,
Yes, sir.
and what are others? Rehan and
Yes,
Arsisman.
sir.
Yes, sir.
Yes, sir.
So you people could understood or not? You have understood or not?
So we'll get through this problem, and if we arise with any doubts, we'll get to know.
Till now you have understood or not?
Just a
If
little bit
no, then
understood, sir.
clarify. Try to clarify. See, you need to have lot of practice, okay? Otherwise, like if you don't practice different problems, okay, then it will be it will be difficult otherwise. If you don't practice, it will be difficult, no? If you practice, it becomes easy. Thing is as simple as that. So similarly, like all those for exam point of view, also cam design you need to like practice, okay, it by properly using all those geometrical instruments and all, not just rough sketching and all. Similarly, this gear design, gear problem also you should practice. Okay? Not only these problems, you at least take just follow any one of the book, okay. Initially try to solve the problems which are in the like given exercise, okay. Solution is already given. After that, go for the exercise, try to solve some unsolved problem. First you try which are solved problems, at least you should have some idea, okay. Only don't rely on suppose the minimum number of problems that we are able to solve in the class. Otherwise, if you don't practice by yourself, it will be not be good. So here we have seen like what are the basic stages involved. First, if required, sometimes you have to draw this diagram as per the question. Most of the times it is given. Sometimes if it is easy, then might not be given. Okay, so from this given data, you should be able to draw this configuration. Then write down all those given data. Okay, try to correlate them with whatever standard notation etc. that is there. So write down the given data. After that, our task will be to make the table showing the motion of various elements. For that, you just try to find out what are the different elements which can exhibit unique motions in that particular epicyclic gear train system. Okay, if there are like just like in the previous case, if there is identical motion that will be shown by identical gas and all, you can have the like as assessment for any either of them. Okay, because others will be exhibiting the exactly same motion. Okay, that is up to you. And also don't forget to consider the arm as one of the element, because in an epicyclic diagram that arm also plays a vital role. Okay, and then initially we consider arm to be fixed, and we give plus 1 revolution in either of the direction to one of the like mostly to the either sun wheel or to the exterior wheel. And based on that, what happens to the motion of other elements that we see. After that, we extend this table for like x revolutions for that particular element. Then we also give motion to the arm and all. Okay, and ultimately the total motion we try to find out, and those whatever in the table we obtain the motion values as. Okay, so those motion we try to equate with the we go for the given conditions in the question, okay, and try to solve for all those x, y, all those values, and ultimately we get the answer. Okay, this is how this kind of problems need to be addressed. So similarly, like okay, this problem maybe we can go in the next class. We will solve in the next class. So for today, we'll stop here. If there is any question, you can ask. If no, then respond to your name first. Nilutpal,
Then, sir.
Shankar, Shankar, absent. Arsisman,
Present, sir.
Rehan,
Then, sir.
Partha,
Then, sir.
Rishikesh Vasumutari,
Present, sir.
Fairmiki,
Present, sir.
Naosal,
Present, sir.
Theza, Theza, absent. Rishikesh Nath, Rishikesh Nath, absent, and Emil.
Present, sir.
Okay. So Shankar, Teja, and Rishikesh Nath are absent. Understood. Okay. So thank you, everyone. We'll meet in the next class. You solve
Thank you,
some
sir.
problems, okay? And practice for class test too.
Okay.
Yes, sir.
Yes.